Lesson 5.1. Our learning target says I can solve inequalities involving one or two steps. And our essential question says how do you graph an inequality? So for the vocabulary, we just have inequality symbols. So inequality symbols, remember inequality symbols are these. So this first one is a less than symbol. And when we're working with graphing inequalities, it's going to be very helpful to remember that less than is represented by an open boundary circle, an array that goes to the left on your number line graph, because numbers are smaller as you move to the left, so less than moves to the left. My second symbol is less than, but it has a line under it, so it's less than or equal to. When graphing, the only difference is you have a filled in circle, because the equal sign underneath the symbol means that you include the boundary number. So the number that your dot is on, your circle is on, is included in your solution. So less than or equal to is a solid circle going to the left. Numbers are less to the left. Next, I have greater than. Greater than, without the line under it, is an open circle going to the right. Numbers are bigger as you move to the right on a number line. And then greater than or equal to is a closed circle because of the line underneath the symbol. So close your circle, make it solid, and greater than goes to the right. So greater than or equal to. Graphing inequalities. So graph each inequality. We have a blank number line drawn, and our inequality says x is greater than -2. So I need the number -2 on my number line. And then looking back at the previous slide, looking back at those shortcuts that I gave you with the arrays, greater than is an open circle to the right. So greater than is an open circle to the right, like this. Now, on the right of -2 on a number line, I'm going to add two more numbers that would be solutions to this inequality. So to the right of -2 would be -1 and 0. So those are two examples of numbers that are greater than -2. Remember that array goes on forever, so there's an infinite number of solutions when your inequality says x is greater than -2. So not just -1 or 0, but anything else to the right would be greater than -2. So inequalities have an infinite number of solutions. The next one says x is less than 4. So I start with 4. If you need to look back at the previous slide, you see that it's an open circle, and less than goes to the left. To the left of 4 would be 3 and 2. My third one, -1. This one, because of the line underneath, means it's going to be a solid or closed circle. Solid or closed circle. So closed circle, and greater than goes to the right. Greater than -1 would be 0 and 1. Now before I move on, I want to make sure that you understand the shortcut. When the variable is on the left-hand side, like these variables, they're all on the left-hand side, your symbol, your inequality symbol, points the same direction as your ray. So see where I am emphasizing? So this greater than symbol matches this ray. The less than symbol, similarly, matches right here, the less than. It goes to the left. So the direction that your symbol points, this one points to the right, This one points to the right. The direction that it points matches. The inequality symbol matches the ray on your number line, as long as your variable's on the left-hand side. All right, 5. So we've got less than or equal to, so closed circle because of the line underneath, and it points. See that this points to the left, points to the left, like that. Now my next one has a variable on the wrong side. So what I'm going to do, anytime my variable's on the wrong side, I am going to reverse it. So if the variable is on the wrong side, you can turn around your inequality like this. You have to flip the entire thing around. So if your symbol is pointing, this greater than or equal to points at the x, notice it still points at the x after I flip it. So x is less than or equal to 1 is what I'm going to graph. So 1, I need a closed circle, and my new symbol is pointing to the left. So on my 5, I forgot to put 2 more numbers. To the left of 5 is 4 and 3. To the left of 1 is 0 and negative 1. One more where the variable is on the wrong side. So if I switch it, it would look like this. So you might want to make a note for yourself. Make sure the variable is on the left before you graph. Otherwise, you may end up drawing your graphs the wrong direction. Okay, so negative 3, and then now that I've switched it, it's a closed circle going to the right. So on the right of negative 3 would be negative 2 and negative 1. Now we're going to do some solving first. So far we had just been graphing inequalities. Now we are going to do some solving, and then we're going to graph our solution. Graph our solution set. So if I write this inequality here, x minus 2 is less than 3, and I solve it. Circle the variable. The inverse of subtracting 2 is adding 2. So add 2 on each side. So x is less than 5. So that would be an open circle, and less than goes to the left. Because this number line has a lot of different numbers on it, I don't have to worry about writing my 3 numbers. Next one. X plus 11 is greater than or equal to 7. The inverse of adding 11 is subtracting 11. So 7 minus 11 is negative 4. Keep the symbol and the x. So negative 4, closed circle this time. And my ray would go to the right. So here's my inequality and my graph. Next one. Negative 2 is less than x minus 3. Now the variable's on the wrong side. I'm not going to switch it until the end though, because I want to make sure that I do the correct action step. So I would need to add 3 on both sides this time. Negative 2 plus 3 is 1. Now I'm going to switch it. Switch it. So x is greater than 1. So switch it at the end. It's an open circle. Greater than goes to the right. If you switch it at the beginning, I'm afraid you might make a mistake with the sign on that. X minus 3 would have to stay in x minus 3. Okay. 1 is greater than or equal to negative 8 plus x. The variable's on the wrong side again, but I'm going to leave it for the time being and add 8 to cancel out the negative 8. 1 plus 8 is 9. So now I can flip it. 9 is greater than or equal to x, or x is less than or equal to 9. Notice the number line. This one doesn't have the correct numbers on it, so I'm just going to get rid of it. Maybe not. Okay, I'm going to draw a number line over here. So we need 9. We need a closed circle. And it's pointing to the left now. So to the left of 9 would be 7 and 8. There. All right, last 2 sets of examples. So what's different on this one is we have a variable on each side. We've solved problems like this before. You might not remember them. What we did when we had a variable on each side was we subtracted the smaller one. So I'm going to subtract away the smaller one from both sides. So 4x minus 3x is 1x. 1x is the same as just x. So you don't have to write the 1 in front of it. Now I'm going to flip this around so that the variable is on the left. So x is greater than 1 is an open circle to the right. So subtract the smaller variable on each side. When you've got a variable on each side, subtract away the smaller one. And then remember that when the coefficient number is just a 1, you don't even have to write it. So smaller variable this time is 4x. Subtract 4x. 5x minus 4x is just 1x. So 1x is greater than or equal to negative 2 is just the same as x. So x is greater than or equal to negative 2. Solid circle, closed circle, pointing to the right. Like that. Our last set of examples. The smaller variable this time is 3x. So subtract 3x. 6 is less than 6x. This one actually has a second step then. So we need to divide by 6 on both sides. So 6 divided by 6 is 1. And then if I flip this one around, x is greater than 1. So it's an open circle going to the right. And my last one. Subtract away the smaller variable. The smaller one this time is 12x. So negative 4 is greater than or equal to 13x minus 12x is 1x. So 1x is just x. And then I can flip it to get the variable on the correct side. X is less than or equal to negative 4. Closed circle. Going to the left. All right, that is it for solving our one-step inequalities with adding or subtracting today.